Hi everyone. This instructional video is about rotation. Let's look at this example. We're given this triangle and we're going to rotate it 180 degrees, and where we're going to pivot, or the point of rotation, is at the origin at 0, 0. So we're basically take this entire triangle and we're going to rotate it like on a record player. We're going to turn it 180 degrees. So what I do is I draw a line from one given vertex through the origin, and what we're going to do is we're going to do this old school, meaning we're going to notch out the actual measurement from the point to the origin, and we're going to transfer that to the opposite side, and voila, what we have is a point A prime, because it's on the 180 degrees opposite side. And we're going to do the same thing where we draw a line from B through the origin and extend that line to the opposite side, and we're also going to measure that, or make a replica of that distance and transfer that onto the opposite side. Ta-da! And that becomes B prime. Same thing with the C. We just simply draw a line from the C vertex through the origin and stretch it out to the opposite side because it's 180 degrees. You see that? That's 180 degrees. And we're going to measure out physically. Where'd it go? Here we are. Physically make a template of that distance and transfer it to the opposite side. Ta-da! Right there. And that becomes C prime. And then when you connect all three vertices, A prime, B prime, C prime, what you have is a triangle that is exactly the same shape and same size, but now it has rotated to the opposite side at 180 degrees. Now let's take a look at the second example. We're going to use the exact same A, B, and C, same coordinate as before, but this time we're going to rotate 90 degrees, only a quarter turn. We're going to rotate it clockwise, just like the direction of a clock's hand. And we're going to still use the origin at the coordinate 0, 0 as the point of rotation. Now, here's a faster and easier way to do this, is by bringing back the patty paper. Because what we're going to do is we're going to use that paper to actually trace all the components of this graph, starting with the X and Y axes, because that's going to help me determine how many degrees to rotate. And I'm going to transfer or trace the actual polygon as well, and I'm going to label them as A, B, and C, knowing that when I rotate it over, it'll be relabeled as A prime, B prime, and C prime. And remember, we're going to rotate only 9 degrees, and we're going to go clockwise. So here it is. I'm going to take my point of my pencil, and I'm going to press down onto the origin. That is my pivot point. And I'm going to hold it there. And I'm going to take the trace paper, the patty paper, and I'm going to rotate this. Look at that. That's old school in action. Remember, if I did 180 degrees, here's 90. If I did 180, remember this one? It's just like before, right there. You see that? Yeah, you could have used the same technique over there as well with the patty paper. But we only want 90, so we're going to match up these axes with the y-axis right here. Ta-da! Bam! And that shows me exactly where the new coordinate A should be. It is going to be, I'm going to transfer that right here. Ta-da! A prime. And B is right here. Ta-da! Right? Yeah. B prime. And C is on the fourth quadrant at 1, 2, 3, and 1. C prime. Now I move that out, and I'm going to connect those new vertices, and what we end up is the actual same shape and same size triangle that is rotated only 90 degrees, not the entire 180. Dig it.